Hey guys, it's Miss Mesker here. I'm recording this video to teach you guys how to find the slope of a line. So what I have here is a regular line. It's a straight line. I can tell that because it's not curved in any way, and it seems to all be going in the same direction without any weird bumps or turns or anything. So I want to know what the slope of this line is. So the way that we do that is by calculating rise over run. A lot of you have heard that. So when I say rise over run, what we're looking at is the the vertical distance, or how far apart these 2 points are height-wise, tall-wise, over or divided by how far apart they are wide or horizontally. Okay, so rise is how far they are apart vertically, and run is how far apart they are horizontally. So slope is the vertical change over the horizontal change, or as we commonly refer to it, rise over run. So let's look back at this line and calculate the slope of it together. So the way we're going to calculate how far apart they are, you can do it a couple different ways. One of the easiest ways is if it's on a cool graph like this, and you know the units of each line and you can easily count them. Go ahead and count the space between the 2 points, and that's a great way to figure out your rise and your run, is by just counting those differences. So this representation kind of has done that for us. So I can count the lines, or the boxes between the 2 points. So I have 1, 2, 3, and then there's my other point. So I know the height difference between these two things is 3. So here we go again. 1, 2, 3. From where this point is on the y-axis to where this point is on the y-axis, there's a difference of 3. And then I could do that for my run. So I could count the boxes between these points horizontally. So I could go 1, 2, 3, 4, 5. So now I know I have a rise of 3, a run of 5. So my slope in this case would be rise over run, so it would be 3 over 5. If you don't feel like counting, another great thing you can do is take the y-coordinate of one point minus the y-coordinate of another point. So in this instance, they have taken the y-coordinate of the green dot, and I can put my little indicators on them to tell us exactly where that is without having to move it around, without having to count myself. So my green dot is at 6, 5, so its x coordinate is 6, its y coordinate is 5. So I would do 5 right here, the y coordinate of one point minus the y coordinate of another. So 5 minus 2. So that's how we got the 3 for our rise. And then I would take the x coordinate of the same point I did first last time. So 6 minus 1. In this instance, they show it over here. So 6 minus 1 is 5. So our run is 5. And so we get, again, the same slope of 3 over 5. So you can do a point and count method, or you can subtract one point's y coordinates and from another point, and same with the x. The key thing to do when we do that, the reason why we have y2 minus y1 and x2 minus x1, is because we want to make sure that we are using the same point first and the same point second in both our rise calculation and our run calculation. So my green coordinates first, subtracting my pink coordinates from that. Okay. Let's make a new line and practice one more time. So I can minimize that. I'll make a different line. I'll make a steeper line. I know this line is steeper because it looks way more like a sharp hill and less like a gradual grade. And so because it's steeper, it should have a higher slope, or a bigger numbered slope. So let's calculate our rise. We could either count the boxes. So here we go. 1, 2, 3, 4, 5. And then I'm at my next point. So I know my rise is 5 this time. And then I'm going to calculate my run by doing 1, 2, 3, calculating 3, counting 3. So I know I need to do 5 over 3 as my rise over run. So my slope in this line's case is 5/3. If I didn't want to do the counting, I could find what my points are and do the y coordinate of 1 point, so 7 minus 2, which is shown here, which equals 5. And then the x coordinates 4 minus 1, which equals 3. So again, doing the math way or the slight subtraction way, I also get the same slope of 5 over 3 for this line. So all you guys need to remember is rise over run, and you will be able to successfully calculate a slope. Just a quick reminder, sometimes slopes can be negative, and we know when slopes will be negative because either the rise or the run will be negative, okay? So if one of them is negative, my slope will be negative. So this case, I have a negative rise, so I know that my slope will be negative. It's also when the line goes instead of down left to right, but up. So this slope is going like this. So it's going starting in the top left-hand corner and working down to the bottom right-hand corner. A positive slope starts in the left-hand corner and works its way up to the right-hand corner. So this is the positive direction. This is the negative direction. Again, it's high in the left and goes down to the right. And we have a negative rise, so we know that our slope will be negative because there'll be a negative number in our fraction. Okay, guys, I hope that helps you calculate slopes of lines. And feel free to refer back to this video or use this PhET simulation if you need to keep practicing.